So for the third examples here, solving equations containing two radicals, the first one's pretty easy because you see we can just square both sides, right? Okay, let's do that. Just square both sides and see what you come up with. You guys work at your seats while I work it here. So it's going to be 8x minus 15 equals 4x plus 5. Yeah, you see how straightforward this is now? As soon as you have a value for x, call it out. Yeah, x equals 5, that's what I got too. Okay, now tell me, when we plug it in, what is this going to work? Well, 8 times 5 minus 15 equals 4 times 5 plus 5. Does it work? 8 times 5 is 40 minus 15 is going to be 25, so that's 5, right? And here we get, yeah, so 5 equals 5, true statement, okay? So that's good. Let's go to this one. You know what, hang on. Let me have you do something before we go any further. There's a phenomenon that I cannot completely explain, let's be honest here. I ran into this yesterday and I thought, well, why does that even work? Okay, what I want you to do is I want you to enter this, this part right here as like in your graphic calculator, not into, well, I guess you could do Desmos. Do you guys like Desmos better when it comes to entering stuff? Okay, so you pick, I don't care. What I want you to enter is two equations. One that says y equals the square root of x minus 15, and then the other one is going to be the second equation, y sub 2, I guess you could call it, is the square root of 4x plus 5. Okay? And what should end up happening is that the two will intersect. Let's see if that actually works. I guess maybe I'll use, did yours? Okay, now, do you know how to use, on your graphing calculator, do you know how to use the trace feature and calculate? Okay, go to that. I guess I'll use Desmos because I've got it here. Y equals, somebody's going to have to dictate this to me. Yes, trying to find the place where those two intersect. Brianna, will you dictate those two?
8x whole square root of 8x minus 15.
8x minus 15. Okay, now what's the next equation?
The other one is
Y equals square root of
4x plus 5.
x plus 5. Okay, yeah, you can see it right here. You guys see that right there? It's 5 comma 5. Now, the what you need to tune into though is what were we solving for here? X or Y? X in our original, right? Okay, so it's this 5 right here, the 5 that's on the left that we're interested in. We don't really care what y equals, but we do care that x equals 5. All right? It is no accident that what we got just a little bit ago, x equals 5, is true. So, if that's the case, we've just proved that this works. What I don't completely understand well enough to explain it to you, it's kind of intuitive for me, but to actually explain why it works is how you can take this and this, break them up into two equations and graph their intersection, and that's the solution for the two. Do you know what I mean? Although it's kind of like substitution. You know how when you have a y equals mx plus b equation and a y equals mx plus b equation, when you're solving for the two of them, you can set them equal to, if both of them equal y, you can set them equal to each other, solve for x, and then solve for y, right? So I think it's almost like working backwards from substitution. Like, for example, like if you have y equals 4x plus 12 and y equals negative 3/7 x minus 15, right? I don't know if that would even, it'd probably come up with a crazy solution. But do you see how if you have this system of equations, you could, because these two both equal y, you could actually set them equal to each other, solve for x, and then you could eventually solve for y. You follow? So I think that's where we're getting at here. It's like we're breaking them back up, graphing them, because that, in some cases, that's the only way to get a solution without losing your brain. Okay? Some of the algebra that goes with some of these more complicated ones is literally above your head. Okay? I had Spencer tried it yesterday. And I didn't even get as far as he did. I was like, oh, it would take forever to do it manually. Okay, so kind of learning how to recognize when you can just graph it and go with it is going to be a good option. Okay, so at any rate, today, notice this says example 3. On your practice problems, there's definitely one that references example 3. You're definitely going to want to graph that one. Okay, so I think what we're going to do here, so that we can kind of keep moving through this, I think I'm going to go with this equation down here at the bottom. Okay, so let's figure out how to enter it into the calculator, into the graphing calculator, right? Okay, so we have y equals 0 over here, so that's not even useful. So let's first kind of break the two equations apart. Let's say y equals, which feels really weird, doesn't it? Because it feels like you're pulling a y out of thin air. So let's say y is equal to the square root of 2x minus 6. Do you see how I've grouped these guys as our first equation? And then as our other equation, it's like we can bring this thing over here, right? So then we get y is equal to, that became positive, which is actually kind of a good situation too, right? So then we get the cubed root of negative 5x, okay? Does that make sense for everybody? Here's what I'm suggesting now. Either in Desmos or your graphing calculator, enter these two equations and see if you can figure out where they intersect. Okay? And I'll do that as well. Y is equal. Be careful. Watch out. Some of you are going to forget to close up your parentheses here after the x. Make sure that negative 6 does not end up under the radical, or you'll get a really crazy answer. All right? Do you know how to do the cubed root or the square root under in Desmos?
Yes.
I don't know how to do square root. I don't know how to do
Cubed root, I think, is in functions. Yeah, like if you go to functions and then maybe under miscellaneous. Yeah, see miscellaneous there?
All you have to do is go to math. Oh, Desmos just did.
In Desmos, you can go to there. Okay, so I guess maybe I'll go y equals. Rebecca, will you dictate that one to me?
Am I dictating?
Both equations, whichever one is. I don't care which one's
Y
first.
equals the square root of 2x.
Square root of 2x. And then I have to, so then I have to go like this to get my, and then,
Minus 6.
okay, minus 6. Now I need my new equation. And then what's my new equation?
Cubed root.
Y equals, are you on Desmos? Okay, you can watch me here. I'm getting ready to do that. Y equals, functions, cubed root, and then what was it? Go ahead, Rebecca. Negative 5x. So negative 5x. Hey, yes, they intersect.
Yeah.
Is that where you guys is intersecting?
Yes.
Okay, let me
4.83.
Okay, let me just scoot this up here and click on it. Yes. Is that what you're getting?
Yeah.
Awesome. So do we care about the y value? Not a bit. But we care about the x value. So let's come back here and we have x equals 4.833?
Yes.
Okay, obviously that's a rounded value. Can you tell?
Yes.
It's fine. Sometimes you got to do what you got to do, right? Basically, we're putting lots of different tools into your tool belt for any kind of ugliness that's going to come with these radical equations. Does that make sense?
No, we just have to prove it by putting it back.
Okay, yes, on these, on the graphing calculator ones, I'm not going to make you go back and prove it, okay? You'll start to develop the sense of when it's going to work and when it's not going to work, okay? Let's go on to the next screen. Here it comes, extraneous solutions, right? You knew it was coming. So here we need to get the radical by itself, so we have square root of x is equal to negative 4, right?
Mm-hmm.
Square both sides, it gives us x equals all of this squared, right? So x equals 16. Nice. Well, now when we're ready to go to the plugging in part, we have 16 minus 4 equals negative 8. 4 minus 4 equals negative 8. Definitely does not make a true statement. Okay? So, solve each equation. There is no solution. Okay? There is no value in that particular problem that is going to work. Okay? All right, so ready for the next one? Let's try it. What do we do to both sides? Okay, it's no accident, people, because I know what's coming. It's no accident that I've been using this with the squared, because do you see that all of this is getting squared? It is not as simple as just saying x squared plus 1 squared. It's this whole binomial squared. Now, can you do all of that in your head? X squared plus 2x plus 1, right? Do you remember this math? You should. And then, obviously, we're squaring this, so that's equal to 2x plus 10. Do you see what we're going to get out of this deal? Yeah, quadratic equation. But you're big enough to handle this. Okay, so let's just bring everything over, right? Or what do you recommend?
X squared minus 9.
X squared minus what? Minus 9 equals, yeah, good. Do you see that this can be factored? Right? What does it factor into, Kaylee?
Is it negative 3 and positive?
X plus 3 and x minus 3. Okay? So what are my two values of x, Noah? Just 3? Also negative 3, right? So plus and minus 3. Okay, now let's take it back in and plug it in. And I'm going to just consistently change the color here so you don't get confused. Okay, so let's do the positive 3 one first. So 3 plus 1 is 4. We'll just plug it in right away. And then do you see how 3 times 2 is 6 plus 10 is 16? Square root of 16 is equal to 4. So we can say square root of 16, and so we can say 4 is equal to 4. Check. Do you follow that this is when I plugged 3 in? Okay? That works. Does everybody see? Okay, now we're ready for negative 3. We're going to plug negative 3 in. Okay, so when we plug negative 3 in, we get negative 3 plus 1 equals negative 3 times 2 plus 10. Okay, so this gives us negative 2, right? And then here we get negative 6 and 10, that's equal to 4, right? Equals 4. Is that true? Definitely not true.
It's negative.
Is it?
Plus 10.
Negative 6, but that equals, oh wait. So that should equal, yeah, thank you. It's just, so this value should be 2, right? But still, either way, well, we need our math right, of course, but negative 2 does not equal negative 2. So what is the solution for this problem? 3, okay? 3 is the only solution. So this proves what can happen. You can have no solutions. You can come up with what you think is going to be 2 solutions, and then only one of them work, right? So there's lots of scenarios that can occur. Are we good? Moving on. Last one. All right, this is just an application for a pendulum, and I think you may have seen this. Have you seen this formula in your work before? I feel like they've used this for other algebra practice before, but now today we're actually using it at a little higher level because now you know how to work with these radicals. So notice that period is referred to as time, and it's in seconds. Okay? See, it says the period is 3 seconds. So we want to find the length. So this is the piece that we're missing, the capital L. So let's just plug in everything we know. We know 3 is equal to 2 pi and L over 9.8. All right, so we divide both sides by 2 pi. Divide both sides by 2 pi. You understand why we're doing that, right? Getting the radical isolated. Okay? Now, well, this cancels, this cancels. What should we do to both sides now? Yes, square it, okay? Now be careful, because you know that 3 squared is equal to 9, right? What is 2 pi squared? Yes, 2 pi squared, but what does that equal? 4 pi squared. You see that? Okay, and just leave it for now, just leave it as pi squared, it's fine. You can work with, and so we get L over 9.8. Where did that radical go? Where did do you see I just copied this down and the radical is gone. Where did it go? We squared it, so it disappeared, right? Now, what math are you going to use to get L by itself? Yeah, you could do that. You can multiply or cross multiply, whatever. That's intuitively I go towards cross multiplication, but it's the same idea. Okay? So I could say 9 times 9.8 is equal to L times 4 pi squared. And then, I mean, the rest, goodness, you can just enter this in your calculator. You've got divided by 4 pi. Wait. Whew, I did this wrong. See how I copied that wrong? Wait. I've gotta go 4 pi squared, leave that inside the parentheses there. So now we have divided by 4 pi squared, divided by 4 pi squared. Does anybody have an answer? 2.23? Yeah, okay, so that's how long the pendulum is. We just talked about this in physical science yesterday. Depending on the length of a pendulum, that's how long it would take to swing back and forth, which is actually very, it makes sense, right? Everybody good? Okay, take you to the next screen here. This is some extra information here. I said G will work best if you use Desmos. You can use your graphing calculator if you prefer that. I don't care what you use. Those of you who are absent, I need you to bring your practice problems finished on Monday.